Thank you very much. Thank you everybody for coming. I'd especially like to say a big thank you to LinuxConf for inviting me to come and speak. And I really want to say a huge thank you to the volunteers, I'm sure we all do. It's been a fantastic conference. They've been a lot of hard work. And for, considering that they'll do it all in their spare time, I think that's fantastic. So thank you to the conference. Good job. Okay. So today I'm going to spend an hour and 40 minutes talking you through material that should probably take 2 days normally, so it's going to be quite a packed agenda. I'm going to assume that you've got no knowledge of Docker, so I'm going to talk at a very basic level about what Docker is, why you'd want to use it. I'm going to introduce some basic terminology. So, for instance, one of the things I found very confusing was what's the difference between a container and an image, so we'll get that cleared up straight away. And some other terminology as well. And then actually, hopefully spend most of the time actually sat using Docker and getting some practice at using it. Okay, now I've tried to put in here the things that I found confusing over the last sort of 18 months or so that I've been using Docker, so hopefully you won't have the same frustrations that I will. So we're in a forest. There are many trees, and I'm going to hopefully lead you through a path. That doesn't mean to say that you won't have your own frustrations, because you'll be following your own path after that, but hopefully you won't hit the same potholes I did. So we're going to look at what Docker is, why it's useful, and then just how to use it. And I want you to be confident enough when you go away from here that you can carry on, because there's a whole lot of things we can't do, we won't have time to do. I've got more material than we can cover. So hopefully we want to take away what I've written and just carry on using it and then take it further. There are things that I can't talk about just because of lack of time and complexity. So Docker security is quite a big topic. We won't be talking about networking. If you are from a DevOps environment, you're used to terms like, you're hearing terms like Kubernetes and Swarm. We won't be talking about this talk is for Docker at the small scale. It'll be particularly useful if you are a developer or a tester. If you're going into a DevOps environment, you'll still need to understand this material, though, to build on top of it. And I won't be able to go into every single gory detail and every command line option. There's lots of them. So you'll need to have the documentation open in front of you while we're working. Okay. Whoops, wrong way. Okay. So hopefully everybody can do this from the command line. Is anybody not able to do this? All right, so you should be able to just flip over to a shell and go Docker version, and then go Docker container run hello world. Who can do that?
Is it a problem if you have to do sudo before that'll work?
If you're on Linux, then you can either keep doing sudo, which is a bit tedious, but the solution is to add yourself to a Docker group, and then log out and log in again, and you'll have the permissions you need. All of the material here is in this GitHub repo. You'll probably want to clone this repo now, because when we start doing exercises, a lot of the exercises are pre-written, so all the material's in the repo. You just got to type in the commands. And there's a Gitter community which I've got open, so if you want to join that and ask any questions either now or in the future, please do so. Okay. Why don't I just hit escape? It does, good. Yeah, that was a discovery of mine yesterday, so that was quite good. I'll just manage to shut down the slideshow. Okay, so a bit about me. So I've been using Linux for a long time. I actually organized the first Linux conference in the UK back in '98, I think. So I'm a mini Musty Russell in that respect. I currently work in developer relations at a software house in Melbourne called Papercut Software, who've actually paid for me to come here. And also my colleagues helped me refine and rehearse this material, so very many thanks to them back in Australia. I really love technology in all its sort of various forms, perhaps sometimes a bit too enthusiastic, and I'm a keen consumer of coffee and craft beer. You can contact me on all the usual places as well if you want to follow up afterwards. So why did I come to Docker? So a few years ago, Docker became very popular. We was talking about Docker. But it was very hard to work out what was going on, and I got very frustrated going to what was supposedly introductory discussions about Docker, and nobody explained to me why I would use it and what problems I could solve and sort of the basic ideas. And so I've always been conscious that it's important to start from that when talking about Docker, and sort of what is the difference between a container and an image, and until you've got those basic understandings, it doesn't make much sense. So that's very much my objective in delivering this sort of talk, is to try and get people bootstrapped into that. So when you talk to people about Docker, you get words like this, what's Docker? Well, it's all these things, and people use various phrases. But if you actually look at that as a phrase on its own, it doesn't really mean very much. So let's talk in a bit of detail about what sort of problems Docker might solve. So I've got a simple model of an application which should be familiar to most people. So we've got the concept of an application or a service, and it's a collection of processes that run on a computer and the resources that they need to actually get useful work done. So a process is a piece of software that's loaded into memory and running. It's a single process. And the process has access to resources. So the resources are all the things external that you need to actually do useful work. Obviously things like files and data in the files, but also permission to access networks, security profiles, and so on and so forth. Yes, that should be all pretty simple. And there's a sort of picture of it, of multiple processes accessing different resources to make something that's useful. Okay, so how could you run that? Well, the obvious thing, you could have a big machine with an operating system, and you just run all these different processes on the machine, and the operating system controls access to the resources. It's a nice, simple model. It's got some problems. One process can consume all the memory and starve all the other processes of resources, or you have to buy a big enough machine with enough headroom to cope with peak capacity, which is a waste, and so on and so forth. So there's a lot of capacity issues with that sort of thing. It's also a complex environment to recreate for development or testing, and not practical. So there's a variety of issues. And of course, one process. Yes, John. Sorry. Yep. If you're on Linux, you'd have to type sudo unless you make yourself a member of the Docker group. Okay. So then, in the late 1990s or so, we got virtual machines. So in virtual machines, we're carving up the computer into different areas, and they're protected by having their own copy of the operating system. So that's the difference. There's multiple copies of the operating system running. Each process is completely isolated from its neighbor. It can only get resources given to its guest operating system. That did a lot, and VMs are very popular still. But they have problems. They're actually quite complex to provision and manage. And it's still hard to actually roll out the same configuration to test and development as you do to production, okay? It's slow to start up. If you're having to start a process and it means booting a VM, it takes a finite amount of time, several minutes in fact, to boot up. And of course, if you're using licensed software, then you've got multiple licensing costs as well. Now, as an aside, we're going to talk about containerization, and that does not mean that VMs disappear. There's still a place for VM technology in the operational environment, so I don't think that VMs are going away, because they're not. They're just changing their role slightly. Okay? So then we come to the concept of a container. So a container is a similar model to virtual machines, but we remove all the guest operating systems. So each of those processes is actually accessing the underlying Linux operating system here. The difference is the container layer is mitigating or is managing that connection and is controlling the access to resources, okay? So each of those processes thinks they're actually running a separate machine, even though they're not. They can only see themselves, they can only see one process, they can only see one set of users they're given access to. They can't consume more resources than they'd be given access to, this type of thing. So they're effectively in a box, in a container, okay? But it's not perfect. It can be hard. Once you've got it working and running, it's very quick and easy to run. generally, but it's actually fairly complex to set up and test and that sort of thing and make sure it's resilient. And if you are going to do this at scale, then you start to need to re-architect some of your applications to use things like microservices. So typically when people think of Docker or containerization, they're thinking of microservice architectures, but a lot of the applications in the world, of course, are not microservice-based. Okay. So having got sort of those ideas out, then if you look at the more formal definition from Wikipedia of containerization, then it starts to make sense. We've got this concept of containers which contain processes that look like real computers to the processes inside them, but in fact are not. They're just effectively a box which you can't, in theory, escape out of, and to which you have granted certain resources. And so they're isolated from each other. So does all that make sense? Yeah? Okay. Oh, by the way, please do feel free to ask questions. I may not be able to answer all of them, but I'll certainly do my best. And if not, I can take things offline and answer them later. Okay. Yeah.
For mining model, would it be best to take true root, but the network and other resources too?
Yes. True root is one of the mechanisms used. There are multiple kernel mechanisms that are used to provide this facility. And I'll give you a reference later so you can discover more. So what's the benefits of this scalability? It's quick and easy to start these workers. You're not starting a guest operating system, you're starting 1 or 2 or 3 processes. So it takes milliseconds to bring up a new container. If a container crashes, you can restart it very quickly and easily. If a container is constrained, so it can't, in theory, run amok and just take over everything else on the machine. Lower costs, you don't have multiple copies of your operating system, you consume a lot less memory. So where you could maybe have 3 virtual machines, you can have 10 or 100 containers. That's a huge saving. And it's now reasonably easy to make your dev and test environments look like production, depending on your dev environment. That's not universally true, but for a lot of developers, and this is the attraction, they can quickly spin up something that's got the same dependencies and the same architecture, albeit at a smaller scale, as production, and it makes it much easier for them. Okay. Okay, so Docker is a technology and it's a company, and they provide, and the Docker product provides you with containerization. So containerization is a generic term. If you look on the Wikipedia page I referenced earlier, there are lists of other containerization products, and they have been around for some time. Docker's not the first one. Okay, but Docker's the most well-known and the one that people are using the most now. It specifically worked on Linux kernel back in the day. There is now ability to run Docker on Windows. I'm not going to talk about that. I don't know much about it. And this is a Linux conference anyway. Okay. There's a really good video here that I recommend by Liz Rice, which actually shows you how to build containerization technology from scratch in Go. So it actually explains how the Linux kernel can run these containers and the facilities that Docker depends upon to make that happen. So it's quite good. And because Docker is so popular, there's lots of material out there to help you. There's lots of tools for orchestration like Kubernetes or Swarm. There's lots of training courses. There's talks at conferences. There's books, there's videos, and so on. Okay, so you get lots. You can get up quickly. Any questions so far? Is it all making sense? Yes. Okay, so they work on top of Docker. So what I'm going to show you today is just running Docker at the small scale, so starting 1, 2, or 3, 4 single application stuff. Things like, so Kubernetes and Swarm are examples of orchestration frameworks. So they allow you to run hundreds of thousands of containers. So often people talk about pets versus cattle. So today we're going to be treating our containers as pets with individual ones. We care about them, we take care of them. When you're running 100,000, you don't care if one drops off the machine, you just start up another one. So the ability to start these machines at scale, or start these containers at scale, monitor them and manage them, that's why you use an orchestration framework. Does that make sense? Okay, two very important pieces of terminology. Docker images. So a Docker image is the sort of the underlying concept of something you need. And all it's got in it is a bunch of files and some metadata. And it should be as small as possible. People can fetishize making it really, really, really small. Sometimes, to the fact it's unproductive. It's like over-optimizing your code. But it doesn't contain a Linux kernel. It's just the additional files you need besides the kernel to make your system work. So it'll have things like Linux packages in it that you might need. If you need a copy of cuts for your application, might be in there. It'll obviously have your compiled program so it can run, any configuration files that might be needed, and then any metadata about what sort of resources it needs, what networking connections, and so on and so forth. And it contains a default startup command so that when the container starts, the default command kicks off, and the whole thing is running. The important thing about an image is it's at rest. It's on the disk. It's not a running process. Okay. Compared to a container. So a container is where you take an image off the disk and you instantiate its contents into a running container. Okay. So it's actually running. It's in flight. It's going. And a container will contain at least one process, obviously. It usually contains more than that, but as few as possible is ideal. And you can use an image to then start as many containers as you want. So if you have a microservices type architecture, then or a load balancing architecture, you can just keep adding more containers from the same image to scale your capacity horizontally. Now, an important thing, which is kind of surprising to people when they first come across, is that a container does not modify the underlying image. So if I start up a container from an image, and the container writes to its file system, and I shut down the container, those changes are gone. There's nothing preserved. Okay, the image is guaranteed to always be the same each time, yes?
So you're saying that file system context, for example, is a container file?
So I'm saying that when the container starts up, it basically has a virtualized file system. It's a virtualized copy of the image, and it can update that. It can update that container file system. But when you shut down and remove the container, that file system disappears, and all you're left with is the original image. Now, I'm going to talk about later on about how you actually do preserve file system changes, but it's outside of the image. Okay, that's for stability, right? So if you have an image, it will always be the same. You're guaranteed it's not going to change. If you start up a container from an image today, it's going to be the same as it was yesterday. No change. Okay. And the important thing to note is that a working application will often consist of multiple containers connected to each other in various fashions to make a working system. Yep. And so the magic phrase to remember is you build images and you run containers. If you keep that in mind, your life will be much happier. Yep, make sense? Okay. Right, let's actually start doing stuff at the command line. So let's actually get an image to run. So the first thing I want to do is to actually pull an image from Docker Hub. And the way you do that is to go Docker. Is that font big enough? Yeah, sure. Up the back. You see us up the rack? Yes? Good. So Docker container. If you've got installed the command completion, by the way, so if you're that works on Mac and Linux. I don't know about Windows, but if you hit the tab key with enough characters, you do get, and you've got completion installed, it will work. So I can go Docker container pull Alpine. And I did something wrong, because it's, of course, Docker image pull. You see, I've been doing this for over a year, and I still get confused between containers and images. Because of the way I got my system set up, I want to fix this, because I don't know why it's doing it. He's wanting me to log into Hub. I don't think most of you will have that problem. I already had it pulled down, so it didn't actually do anything except check the SHA. Yes, John?
The image, does it just
It does, yes. So you have a local library. So I have Docker client installed here. Not that's all. Well, obviously I've got Docker engine, but I'm running Docker client and Docker engine. So when I have a local library of images, and it's just pulled that image into that library. Yeah. So it's not done anything with it. It's just sat there, and I can actually look at it. So if I go Docker image ls, I've actually got quite a few images. I don't have a laser pointer. There is my Alpine image that was, and it was built by somebody else 4 weeks ago. I didn't build that. Okay. I'm putting it from a place called hub.docker.com, which is a website. It's the world's biggest website of images. There are thousands, and I have 4 up there, which you'll be pulling images from my Docker Hub account later on. It's a bit like GitHub in that respect, in that it's a place where projects can put images for other people to use. So if I've got an image, I can actually look in it. So if I go Docker image inspect, don't worry about this too much because you're going to go and do an activity where you do all this in a minute. Inspect Alpine latest, and that's command completion. I type ALP, hit tab, and it filled in everything else for me. So that's really quite useful. And I get lots and lots of information, which I'm not going to take you through. But you can actually inspect all sorts of things. Well, you can inspect images, you can inspect containers when they're running, you can inspect networks, which we won't talk about, you can inspect volumes. So they've all got this and this is the metadata I talked about earlier. An image has metadata. This is the metadata for an image. And some of the useful things are, for instance, the command. Oh, there's a shadow. Do you see the shadow? The command it will run is under that CMD heading in the container configuration stanza. Yeah, and there's also the path it uses and so on. But I'm not going to look at that in detail now. Okay. Right. Let us do some work. Everybody should be able to go to the workbook on GitHub. And hopefully you can start doing tasks 1 to 8. Yep. Do you know where I mean? If I go, there we go, Docker for Novices. So here, and then if you go to the wiki section here, there's a workbook. So you too will pull from Docker. I've been not able to find that. Yeah. No. Yeah, I like the geek. Yeah. So that's the workbook. Yes. Oh yes. Sorry, my mistake. I didn't update that slide. My apologies. That's the URL. You can read that. Let me just quickly update that. Whoops, gone too far. I have lots of slides, most of which I hope not to show. Why is this so slow? I can't edit the slides for the moment. Just try and read it off there. If you can't read it off there, let me know. Oh, Good tips, thank you. Anybody lost? Sorry? Yes, yep. If you trust me. Okay.
Are you able to run through those tasks with them
Yeah, I certainly can. You can just, so I did the pull, I did the inspect. There's a better version of the inspect command here. So you actually get out, so that's a way of actually extracting a specific information from inspect, because it's all JSON, so you can use a JSON format to extract the information. Right, I can actually run it. So that is a container shell prompt. So I'm actually inside a container. So if I go PS, I've only got two processes running. One is the shell that's running in the container, and the other one's the PS command running on top of that. If I look, okay, I get the whole thing. It behaves slightly differently under Mac and Linux. What else could there? Anyway, that's the one in container. You should read the notes about the IT option, by the way. That's pretty important. And to actually, if you actually look at this, so if you go Docker contain ls-a, that container is still running. In fact, they're all still running. So you actually got to type in an extra command, which is Docker container rm. And now, if you do a $ls, it's gone. Now, I did actually start hello world a couple of times, so I need to get rid of those as well. So an alternative to using the name is to use the ID, which is this magic SHA number, like 55FB. So if I do that, I've lost both. Why haven't? Oh yeah. I've got rid of one of them, and if I do the other one, so now I have I have all the containers missing.
So you only type the first 4 digits.
Yeah.
You'll need that starter at those.
Okay, so it's like okay, first of all, here's a tip. You often hear people talk about, registries and registries and repos in Docker are just like GitLab, and it's not true, or GitHub, it's not true. There are some similarities, but they are different enough to be confusing. So don't use that model. Having said that, every image and every layer and every image and sort of every object pretty much in Docker has one of these unique IDs, which is basically a SHA. I can use the sim technique. As long as you type enough to be unique, it will know what you're talking about. So I could probably use the first 2 or even the first 1. Yep. You get nothing. That is because, I'm glad you asked that. I've got a demonstration of that. Sorry, what was your question?
My question was if the top-line process is it.
Okay, I'll demonstrate that right now. They're both the same question. Okay. So what I haven't talked about, and it's in the slides, but I'm not going to talk about it in the slides, I'm going to just demonstrate it, is a thing called the container lifecycle, okay, which is part of what you're doing. So I actually have a script that shows some of this off. So So what I'm doing now is I'm running through a series of Docker commands with some textual explanation of what they mean, and I'll also expand on it. So the first thing we're going to do is that we're going to run a Docker container called Alpine, and instead of it being interactive, I'm going to use the -D option. It's going to go into the background and just do some work. So just sit there. Okay. And what that does is it actually runs a little script fragment that just prints out an integer every 5 seconds. So it's giving me back, again, going back to this idea that everything in Docker has a unique number. There's the full SHA for that container, so it's actually quite long. Okay. Now, because the container is running, I can run docker container ls. Yeah. And it tells me the container ID, it tells me the image it came from, it tells me the command it's currently running, which is a while loop, when it's created, and its status. Okay, status is important. This is up. It's been up 25 seconds. Okay. It also has a name. It generates if you don't give it a name, it generates a random name, which we can't see because it's scrolled off to the right. Okay. Now, do you remember I did an inspect of an image? I can also do an inspect of a container, so I can see, so as well as the image having metadata when it's actually just on the disk, once the container is running, it also has metadata, and I can look at that with the inspect command. So if I hit the inspect command, I just get loads and loads of JSON scrolling off the top. So if I pipe it through less, that's a bit more useful. I can see the image it came from. I can see the command it's running. So if you look at the top there, there's the actual while loop that's going on that got passed to it, and there's a bunch of other information which we won't bother looking at right now. That's quite tedious. So here's a version of the inspect command that uses another one of these format modifiers to actually just extract a single piece of information. In this case, it's the status. So the status is running, okay? So we went to not running to running. I can now stop the container, so I issue the stop command, so it's Docker container stop, name of my container, not the name of my image, the name of my container. Okay. And that will take a few seconds, because remember there's a while loop going, so it's actually got to kill the while loop. So I think it issues a kill, and then eventually gets bored and issues a kill 9 or something. It's documented somewhere. Okay. And so we did the stop. Now, the thing to note is, if you do docker container ls again, you get nothing. The list is empty. But if I do the inspect command again, so it's the same inspect command to just get the status is exited. And if I run docker container ls -a, which is what this is about to do, then it's actually in the list. It just didn't appear unless we put the -a in, because its status is now exited. So it's still in memory. No file system change has been thrown away. The logs are still there. I could look at the logs. I could reattach to it and start fiddling with it. I can actually start it again, which I'll do in a minute. So it's still a chunk of allocated process space, albeit one that's not doing anything. Okay, it's in a special Docker state. So if I run the start command, I can crank it up again. So you see what? Is that any better? That's worse. Yeah, I have unmaximized it, but I can't pull it back. Pardon? No, because if I maximize it, I do that. Oh, no, sorry, you're right. There we are. Thanks for that. Why is that still? Oh, let me close Slack. Right. So I just ran container start. So it was exited. I've now ran start. It's come back up again, and the status is off the bottom of the screen. Is that right? Right. Sorry. The status is now running, okay? And now it's running, I can actually attach a terminal to it. So remember, it was in daemon mode, it was in detached mode. So if I go attach MyAlpine, I'm now attached, and now I can start seeing these numbers coming out. So it's been sat there for 22 times 5 seconds, running, except for the time it's suspended, and it's just hitting numbers. So if I hit Control C, because I'm bored, it will finish. So now, because it was attached to the terminal, and I've killed the process that was running inside it through the terminal, it's gone back to exited. So I didn't actually have to do stop. Because I hit Control C inside it, it's gone to exited. Why do I stop? Why is these notifications coming? So now actually, if I, to actually get rid of, so now it's stopped, I actually need to remove it, okay? So if you stop a container, it's not enough, you actually have to remove it. And you remove it with the rm command, so it's docker container rm. And now, if I do docker container ls-a, that list is truly empty. And if I do the status command, it says, well, I can't find that container to do the status command on, or to do the inspect command. So it actually just gives an error, okay? Now, if you haven't stopped a container and you want to remove it, you can use the -f. But like in Linux file systems, -f is to be used with care. Okay. So that's the container lifecycle. So if you carry on through those tasks, that'll actually give you a practical experience of hopefully understanding that. Hopefully that answered the 2 questions up this side about that. There's a Control PQ option, which I've never got to work successfully. Yeah.
Instead of attaching to the currently running process, can you attach a new terminal?
You can indeed. There's an exact option. So you can actually, so if you have a running container that's doing something or other, you can actually start a new shell on it and inspect it as it's going along. That's with the attach command. Good question. So that's worth remembering, attach. I can't remember if it's in the workbook or not. One thing I didn't say is that we have far more material than we can cover. I don't know if I mentioned that. So I don't expect you to finish all the tasks before we have to move on to the next lot, because we are short of time.
So if you execute a new shell on container and then you potentially connect.
Sorry?
If you execute a new shell on container, attention there, Control C out, while it calls container.
No, well, because there's another process running.
Okay.
Oops, I accidentally got the stream going. I have such an ego, I have to watch my own live stream. So, everybody happy? Is anybody lost? No? Good. Is this useful information? Learning stuff? Good. Getting some thumbs up at the back. Yeah.
So I stopped one with the Portuguese thing,
Can't see. That's not going to work very well, is it? Thanks. Docker run -d. Oh, it would have exited immediately. Because it should have started. Yeah, because it's in the background, so just starting a shell. Because you have to give it a command to run.
Oh, because it's just
Yeah, yeah.
So I'm just doing the hello world one,
Yeah,
which is here. My one's called quizzical cell.
yeah.
And I'm trying to just get a bash prompt.
You've got it, that's it. Oh, hang on, no, you haven't. So you started it, so you've now got to, you can now exec. So you can type, instead of typing out, just to B6D.
So I should be able to go to doc and ID.
Yeah.
And bash.
Yep. Oh, no, not bash won't work.
Oh, just
That's it.
decode.
No, try SH.
Okay, just like that.
Yep.
Get this.
Okay, do a, so what's your status? You exited, it's not running. Yeah, do start. Use the start command.
Just stop the container stuff.
Yep, with the same. You don't need the SH, that'll cause an error.
Oh, I see, and now I can run that. I'm still getting that.
Okay, so how did you start it?
Like Docker containers.
No, how did you start it originally? You probably want to kill it and start it again. So do a docker rm remove, docker container rm, container ID. So gone. Okay, so now do the original docker container run command. Let's see how you did that.
Back earlier, I just did that Docker container run hello.
Right, that actually doesn't just hang around. That doesn't. It just prints out hello world and then exits. You want to be running Alpine.
I see. Right, so that's just a very minimal
Yeah.
thing there.
Yeah. Alpine is the image that will give you a shell by default. Yep. Yes.
They seem to get the same output.
PS versus LS.
Yeah.
But you can do. The interesting thing, if you do docker ps minus q a, you will get just a list of IDs, which is quite useful. Yeah. So I use that to feed it into other things like docker rm. Okay, so don't forget to RTFM, read the fine manual. There's lots of documentation on stuff. Probably a little aside here, Docker is an evolving product, so things change quickly. It's one of the reasons you want to be on a reasonably modern version. And the documentation doesn't always follow or is a bit patchy. The good news is there's an edit button, so if you see something, you actually go on the website and edit their docs. So if you do see something, I encourage you to do that. But information can be repeated in multiple places and so on and so forth. So it takes a bit of practice, but there's lots of information there. It gets a bit tedious typing all these commands. So shell alias is your friend. There's an example here. Throughout the rest of this workshop, the workshop notes and I will use these aliases at the bottom. They're quite useful. But you can create quite sophisticated aliases, and I've put a couple of links in the further reading section with links to people who've posted lots and lots of very complex aliases. Yes?
So for those of us that stuck typing sudo, do we add sudo?
You could, but
You have to.
you can do, yep. But it's easier just to add yourself to the Docker group and log back in, log out and log back in again. Okay. If you're on Mac or Windows, how many people here on Linux? Oh, okay, most of you. I thought it'd be the other way, because usually you do these things with people running on Macs and Windows. So the problems are slightly different. So nobody's running Docker machine. Yes, Fantastic. Docker machine's slightly different.
What is it for?
Docker machine, so Docker machine is useful for two people. Firstly, people who have platforms that don't support the current Docker deployment on Mac, you know, the sort of default deployment. So if you've got an old version of Windows or an old version of a Mac or so on, then use Docker machine, because that depends on VirtualBox. So using different technology. The other reason for using Docker machine is because it allows you to deploy to any machine. So because it works with things like VirtualBox, if you wanted to provision a different machine, you can use Docker machine from your workstation. However, in the new release of Docker, like 1809, they've introduced an SSH facility. So it's not clear to me still why you'd use Docker machine, but I'm not a systems administration guy, so I'm not an expert, so don't take anything I say seriously on that regard. Yeah.
Either on my Linux 64 or my Windows 10 enterprise machine or a Raspberry Pi.
No. Because remember, you're still running binaries. Yeah? So, you know, you're still making system calls, you're still running on hardware. So on a Linux box, because there's nothing sort of between you and the hardware, on a Linux box, you're effectively, the process that's running inside the container is a normal process. So it still gets CPU cycles, it's still managed by the kernel, but it's just controlled by the containerization layer. You can run Docker on Pi, by the way, there are things to do that. Sorry, yeah, is that not in the instructions? Ah, bad boy. I made the rookie mistake, which I still make all the time, which is minus I minus T. So yeah, yeah. Okay, I might press on if that's okay. So because we've done that, we don't need to we don't need to go through a lot of these slides. Yes, I'm sure you're pleased as well as I am. I will update this slide because all these links are slightly wrong because I moved all the stuff that's marked out like the geek. I moved into Docker for Novices. We talked about that. Okay, let's talk about network ports. So I talked about the fact that all these containers are isolated, right? Which means they can't write to network, they can't write to disks, they can't do anything. Well, they can do stuff, but they can't actually do anything with the information, or they can't get new information. So we have to fix that because otherwise they're useless. So we need to find very controlled ways of exposing information, sinks and sources to the container. And one of the ways to do that is to give them access to a network port. Okay? Now, you use what's called port mapping. It's also called publishing. So bit of mix up in terminology. You'll see it referred to in both in docs. But the idea is that a specific port on the container is exposed to the outside world on another port on the engine box. Okay? So for this example here, I'm running the Nginx. I'm running the Nginx web server, okay? And Nginx by default publishes on port 80. So inside the container, the Nginx process is listening on port 80 for stuff. And what this minus publish option does is say, okay, so inside the container it's port 80, on the outside to the outside world it's port 8089, and anything that comes in on 8089 will get sent to the container on port 80. Yeah? I did want to write a picture for this, but I didn't have time. So that makes sense? Yeah? So that means that you can just take this. We have don't worry about doing the same example. because there's an activity to do this which is different. So if I just run this container, it's actually going to download the image. Doesn't take very long. I wrote all these examples to work really fast across poor conference Wi-Fi, and it turns out our Wi-Fi is really good, but it means it still runs fairly fast. Yep. All of them, 0, 0, 0, 0. Yes. Good question. Right, come on, start up. Oh.
Sorry, is that internal interfaces or your...
All interfaces, so you can connect.
Not of the container.
No, so you can connect into this machine on port 089 and you'll get into the Nginx box. I didn't run it in daemon mode, so it's blocked. Never mind. That is why we have multiple tabs. So now I can just hit that endpoint. Whoops. And there's the default Nginx index.html file. Yeah? Makes sense? So here's a tip. I could never work out which way around those numbers went. So what I do is I remember that it's outside and then inside, and I draw an arrow, going from the outside to the inside, and that applies to the volume command as well. Although we'll be using mount, which doesn't quite work that way. But if you see publish or -p, or you see volumes or things like that, and you can't remember which is which, it's always, this is the outside on the left and the inside's on the right, and the information is going from one to the other. Hope that mnemonic helps.
Can that be part of the
I'm going to say no. So what you do is on the metadata you say I'm going to publish port 80. But you can only specify which port at runtime. So you actually have to include that line. Yep, what question there? I don't know what you call it, natting. I'm not a good enough network guy.
Yes, it's horrible nat hacking and IP tables.
Thank you. There you go. Now, this is not the same as Docker networking. Okay, I did say I wouldn't talk about networking, so I'm now going to lie. One of the things we won't be doing is we won't be setting up container networks. So you can actually set up a whole networking infrastructure inside the Docker engine and across Docker engines. So you've got multiple machines all running Docker containers, which you need for your application. You can set up all these virtual networks between them. But that's completely outside the scope and not something I know a huge amount about anyway. Okay, but this is port mapping, and that is really common. So it's so common that we've got an exercise to do it. Task 9. So this is a completely different example. I've actually written an API server that you can run and hit. And the source code and all the Docker build stuff is all in that repo. So it's not when you run it, it's just going to work. But what you can then do later on is go back and look at how I set it up and built it. Okay. Which is the real value. Just cutting and pasting stuff doesn't actually teach you much.
So that one passes through network interfaces. Is it possible to pass through things like USB devices or Bluetooth devices?
Yes, you can, but using a completely different mechanism. So there are various options to do sound and things. But yeah, I've never used them.
So when the Cyclic container, it's binding onto the on what looks to be localhost.
Yes.
And so that gets translated to maybe
Yes. I don't know how, but I'd be surprised if that didn't work because, you know, this stuff's used at scale. So how would you work at a scale environment if you couldn't do that? But I don't know how. Good question. Anybody stuck? Sorry? Okay. Sorry?
Stop that mining.
Stop it, you should be able to just go RM minus F and kill it.
I was trying sudo docker kill my API and I kind of get permission denied. I started Googling it and it was like, stop.
No, not docker kill, it's docker RM minus RF. Remove minus first. Okay. Anybody not finished? I have a bad knee, so excuse me if I sit down. I wrote to my wife that I was feeling nervous, so she's... Is that going to be on YouTube? Okay, I think I killed it. Okay, can I, yep. Yeah. Yes, you can do that because you, the Docker daemon's running with root privilege. It's just people don't usually do it, but yes, you can. And you can map 80. So what you also quite common see is 80 to 80. So people put 80 on both sides of that colon. Well, it will do if there's something already running on 80, but yeah. Sorry? Oh. Oops. Okay, can I press on? So file storage. So that's kind of one of the major missing pieces. How do you sort of read and write files, databases, configuration files, whatever. The correct way to do it is to use volumes. So this diagram's not fantastic, but the idea here is to show that volumes are managed and controlled by Docker. So what you do is that you say, I want to create a volume, and Docker will create the volume for you, and it will mount it into the file system of the container. And every time the system read and writes, or sorry, the container read and writes to that volume, to that mounted file system, it will it will go to the volume, and then the volume persists beyond the lifetime of the container. Okay? Mounts are sort of the same thing but different. So a mount is a directory that you say to Docker, here's a directory and I want you to mount it into the process, into the Docker container. So it's not a question of saying to Docker, please create me a volume and manage it. It's here is a directory, just mount it. So if you're a developer, that's really useful because you can put your source code and stuff on that, bring up your development doc container and start working, and we actually have a little exercise to do that. But a volume is different. So if you've got a database file, you say write to Docker, and again, we've got an exercise to do this, Docker, I want a database directory, you manage it. And to back that up and to manage it, use other Docker containers to create your tar files or whatever backups, okay? So it's squirreled away somewhere inside the Docker file system. You don't have to worry about it. But with a mount, you have to worry about it. Now, the reason I'm talking about this is because volumes are very clearly what you should be using in production environments. You should not be using mounts. Now, there are possibly some use cases where that's not true, but generally using a mount in a production environment or even perhaps a QA environment is a bad smell. If you're a developer, then the only things that should be in your mount points are things like your source code that don't need to move with the container. Okay, they're just things that you need to use whilst you're using the container. Is that difference obvious or not obvious, but does it make sense? Yeah, okay. So, okay. I think this is, so here's an example. So this example is a bind mount. So that diagram is actually slightly wrong. It should say a bind mount and data volume. So here we have a container that's running. It's the Nginx container again. And I'm bind mounting the Nginx HTML folder into a local. That example is incorrect, and I apologize. It's wrong. That should say volume, not bind. So what I'm saying here, ignore that. There's a bind. This is the correct bind mount. This example should say volume where it says bind, and this is a volume that's managed by Docker. So what I'm doing is I'm saying to Docker, please create and manage a volume for me, and when this container starts, map that space to the HTML directory for Nginx. Okay, and that means the contents of the HTML documents are preserved, but there's a typo in it. And of course, we've still got the publish. This one is a mount. Now, apart from the fact that the type is different, where it says bind, it should have said volume in the previous one. The only difference is the way that the name's specified. So if you notice where the source is, I actually put a directory name, not a name. I put the name, the value of a directory path, not the name that something will be created over. So you can go and do examples 10, 11. Oh, probably any questions about that before we carry on? Yeah.
Does the volume, is it associated with the container?
No.
Or the image, or is it independent of both?
It's independent of both. Good question. Yeah. Yeah, it wasn't clear. Now, one thing that I emphasize in the workbook, and I'll just do this verbally, is you notice here I'm using minus mount. Sorry, let's do the correct example. Minus mount. When you go out in the big wide world, when I let you loose, all the examples you'll see use minus v instead. Minus v doesn't use that format. It just uses source and destination, and the only way you can tell the difference is the fact that for a bind mount, it's a full directory path, and for a volume, it's a name. And all you do is missing that / at the front to tell you it's a directory path. So it's really easy thing to miss. So this is now the preferred format, but you will undoubtedly see majority of people using the minus volume option or the minus V option, which doesn't specify it explicitly like this. Yes?
Just curious, with volume mounts, does the source name represent any real directory or any?
No. It does map. You can discover where the directory is, but it's not a directory you have to worry about because, like I said, when you actually come to need to back it up or copy it to move it, then you say to Docker, okay, please copy this stuff out for me to standard output, and I will then put it into a tar archive or whatever. Yeah.
Not intended to.
No. Wouldn't be hard to do, but yeah, it's not the way it's meant to work. Yeah. Any questions? Let me do the exercise as well. 10, 11.
Are there any containers or
The only thing that Docker creates for you are 3 different networks, but you don't care about those. So I can repeat the questions. The question was there any special containers or images or stuff or volumes that Docker creates for you that you shouldn't delete? And the answer is no. The only thing is Docker creates is 3 different networks, and you can't delete those. So. Anybody finished this yet?
That mount is created and read write. Is there a way
I hope so.
to read only?
Yes, you can add extra parameters to the mount option to make it read only.
So the container would be able to read the files that are close to
Correct. Correct. Yep. File P, file set. Why have I got file set? Because I'm up here. There's actually a small bougette in the instructions. So if you go to file set B, so make that current your directory like it says you should do in the workbook. Oh, hang on. No, it doesn't. Sorry. I misread my instructions. Right, so that's now running. So if I go, there's my example code. So I go Lua. In fact, I don't have to do that because I've got it all set up. Oh dear, there's a bug. Is anybody having trouble with the exercise? Can anybody spot the bug? I had no idea what the skill level of people that would turn up, so I decided not to make it too hard. Save that. It works. And we've got new jobs for a Lua programmer. Anybody had trouble with that? No? Okay. Does, yeah.
I actually fixed it inside the formula.
Okay.
Well, I think
Yeah, that's exactly right, yeah.
Just a little question, the dash RN, so when you try to exit from that container, the container was cleared out. The fact that they normally hang around to the pod, so why would you sometimes
Because so if it's hanging around, you can restart it. So that's one reason. You can start it again. You can run diagnostics on it, so you still got access to the log. If it's still hanging around, you still got access to the logs. You can still look at the file system, because remember that a container can change its file system. It's just that when the container is removed, those changes get lost. So you can still look at its file system, and so if you sort of got to debug your container, that's why you want it hanging around. But once it's stable, then I always use the --RM option. And it is 2 minuses, because it's short for remove. It's not 2 single flag options. Yep.
Just back on the volume.
Yeah.
If I spin up a Postgres container
Yeah.
with volume, is there anything to prevent me starting up another old Postgres container?
So the question was, if I start up a database server with access to a volume, and I set up another, however many other database servers and point them at the same volume, does it stop me? I don't think so, but I've never tried and never looked, so it's a good question.
I guess a more generic question would be, if the file is not inside a container, does that not get passed up to?
I think it does. But I've never tested. I don't know for sure. Because at the end of the day, you're still on a file system. It's still remember it's one Linux kernel. So you're not that isolated. Pardon? It'll still be in the lock table. I don't think it's got a separate lock table. Okay. Has everybody managed to do the volumes one? So I created a database example using SQLite because it's teeny tiny, but it still illustrates the point. So what this is doing is downloading another image I created, and all this does is run SQLite. So I'm passing a create table command to SQLite, and it's created the table for me. But notice I haven't got a volume command in there. So when I then try and run an insert on the same table, I'm sure you can all guess what's going to happen. No such table. The table's because it's a different container. Same image, different container. Yeah, so any change I made in the first container is gone, and it can't sit in the second container. So the way you do that is that you pass well, first of all, make sure you can actually look at volumes, because they're things. So there is no volume, or no volumes. So now I can start running these commands, exactly the same command, except it's got the minus minus mount option. So I created a table, and this time if I do volume analysis, it's actually created a dB demo volume. And so now I could run an insert on that. And it worked. And of course the select will work as well. Tra-la. Make sense? Yep. Sorry. Three independent containers, yep. Correct. And now you can just delete the volume if you want. So, you know, volume's a thing, and I can go docker volume rm db demo, and it's gone. So if I try and run that select again, no such table. So I've lost all my data. Used volume rm with care was the lesson. Okay. Sorry, say that again. You get a what? Okay. Don't know why, because I made sure all my repos were private, public. Okay, I'll go through the material and then I'll come and see if anybody else gets the same problem. Okay. Oh, okay, that's a shame. Right. Let's talk about environment variables. So,
Sorry, one quick question.
yeah.
Just to reiterate what you said before, by mounting computers on the dev machine to an exposure system,
Yep.
so that your would use the volume in production.
Oh, are you talking about building your software? Okay, so I mean, so there are various patterns for doing that, but yes, you could do that. But another way would be to actually have a separate container you git clone into, build the software, and then you deploy the built software from one container to the other. So you never git clone into the production image or container. Yeah, make sense? Okay. Right, passing it. So we've talked about volumes, which is sort of I/O. You can read stuff and you can write stuff. We've talked about network ports, which is about reading stuff and passing information back. We're going to talk about environment values. So this is sort of classic, you know, sort of environment strings that you pass in out. They're obviously read-only. It's a way of getting information into the container, but you can't get information out, which should be, you know, you should be used to that from the way that subshells work. So there's a -e option. So this works when you're doing a container run command, and you pass it a -e option. So there's an example down there. And an important point about environment variables is that it's tempting to pass secrets and other bits of security information using environment variables, but they're not secure, so don't do that. There are other mechanisms which you'll need to go and discover to actually allow you to, and there are newer mechanisms out with the very latest release of Docker to actually allow you to securely pass secrets around when you're building images and things like that, or running images. So don't use environment variables. But for other things, they're quite useful. So here's a really simple example. So if I run the Alpine image, minus RM, minus RT, Alpine. So notice that so just as an aside, I didn't type anything after the Alpine, so I've actually got a shell in there. So I can do the usual things. If I exit from that, and I used minus RM so I don't have to remove it, but if I give it another command like env, it will run that command and exit. So that's really useful for little demos like this. So the env command, for those who don't know, prints out all my environment values. So by default, you only get 4 environment variables: path, term, home, and also the host name. Okay? But by using the -e option, I can pass in extra stuff. So the first example, if I just type in the name of an environment variable, that will be taken from my environment. So the current environment has that. Just to prove that, let's just... So currently LCI time is set to Australia. If I go -e LC time, then, hey presto, the container gets a copy of that as well. Okay? If I want to pass something different, I just say equals and then some other string. So engb utf dot -8. And suddenly the container's in GB locale. So that's how you pass environment variables in. Yeah. Task 12, please. Right. You had a problem. Okay, that's kind of weird. I have tested these. Where are we? Number 12. Ah. Yes, different, or you, no, hang on. Okay, yeah, I need to fix that. I'm not sure if that, will that work? Where does that come from? So for the time being, could you just follow the instructions? Sorry, what's your name? This is the instructions that Anita posted in the Gitter repository, the Gitter chat. Thanks for that. And my apologies again for the mistake. So everybody got access to that? Can I flip away? Yeah, I'm missing a build. Bad. I'll fix that later today and it'll work. Won't waste everybody's time. This example, by the way, is these examples are going to get more and more complicated and have more and more moving parts. So if the actual example doesn't make sense because I'm using a profile login file, let me know. So just apply Anita's fix. Of course, that won't work. it works, if you make that small fix. What time's lunch? 12:30? 12:20, okay. Okay. Container logs. Let's start going this. Everything that gets written to a container standard out or standard error is considered to be a log, and Docker will save it for you for a certain amount of time. It's actually a buffer. So eventually it will get overwritten. And there's a command called Docker container logs, and you give it a container reference, and it will spew out what it's seen so far. And if you use the ---- follow option, it will behave like tail -f. Okay, pretty simple. I'm going to skip the next.
If you attach like
So I don't understand the question.
So if you can Docker run, you run one process, and then you can Docker extend while it's still running.
Oh, you mean in the same? So it's whatever's on the container standard out and standard in. So it's whatever is connected when you do Docker run. Yeah. Okay. Very quickly, we need to talk about how to create your own images. Okay. So you need to write an image. You need to create a Docker file, which is a list of instructions to Docker, and then you run Docker build. So here's an example Docker file. It's very simple, but it shows some important elements. The first thing a Docker file is the base image from which you are pulling. So what will happen is that Docker will see this, and it will pull Alpine 3.8 down, and will then build all the other stuff on top of that image. You can get scratch images with basically nothing in them. Okay. You need to provide some metadata, so it's always expected that you provide the maintainer and description labels, and that just gets embedded into the JSON that we saw earlier on. Next is where you start doing run commands. So this is actually an instruction to Docker to basically instantiate this image as a container and then run these commands and then store the results away as the new image. So in this case, it's something very simple. It's just running a package manager to install Lua. And the last thing is the default command. So this is the command that will be run when the container starts up. In this case, it's just running bash. Sorry, not bash. It's running the shell, and it's then running the Lua -version command. Okay, that's all it does. Now you will see a lot more in Docker files, but this is the basic simple stuff. The other thing that you will see, which I haven't got in here, is a copy. So if you look at the Docker files I supplied for the last example, with the profile file is actually a copy to copy in the profile file. So that's the majority of what you'll see. The build command, you can have a default Docker file name, but I prefer to use something a bit more descriptive, and therefore I have to use the -f option. But I always put Docker file at the end of it. You give it a friendly name, so it's called a tag. And the tag includes the tag at the end. So it's a bit confusing because the bit after the colon is also called a tag. So I prefer to use the word alias for this. This collection of this string is an alias, and it consists of a name followed by a tag. But to do that, you use the -t option. Okay. And the thing that you always forget is the build context, that little dot at the end. You have to give it the name of the directory which contains all the files that you will need to build this, even if there are none. Okay? So if there are no, so in the previous example, I'm not copying any files in, so there's no external files needed for this example. So I have to give the name of an empty, well, I can give the name of any directory, just the files won't be used. But you always have to have that directory there. So you often see a dot, and the dot is actually quite easy to miss when you're reading it, so be careful. Yes, is the answer. You build Docker containers for all sorts of purposes. and it depends on your particular environment and workflow what you'll build. But you've got flexibility, so you can build it whatever you want. So we're very short of time. You can start this exercise, but in 5 minutes we'll be moving on to something else. But I would suggest you start with task 14. And then there are a bunch of other follow-up tasks where we build more and more complex images, which you can do afterwards and ask me questions through the Gitter forum. It's probably easiest, but go for task 14 for 5 minutes, see how you get on. Yeah. Yeah. Yes. Do not use the, so you'll find that most images have a latest tag, right? So you see, so people will either use the term latest or they will just leave it blank and therefore pick up latest because that's a default. Don't do that, okay? The reason for not doing that is there is a convention that latest is the current production version. That's the convention, but it's just a convention. And it may be very out of date. It may change. So, you build software on a specific version, which happens to be latest. So you use a latest tag. And then next week, they update the image, or they relabel a new image with the latest tag, and the old one doesn't have it anymore. You rebuild, and suddenly you've got a different version of your under your software, and something breaks. So I don't know, was anybody at Elastic workshop yesterday? Where they said, we don't use latest, and I think that's dead right. But when you are building Docker file, when you're using Docker files, always explicitly put the version that you want to use. Otherwise, things will change under you. They have used, sorry?
Latest version at the time we recording and then we use it for next session.
No. If you use latest there, and you rerun the build, you get a different version from Docker Hub, or you risk getting a different version. So don't use latest.
Before we build it, we need to submit what?
Yes, correct, yes.
Just wondering, is there any particular reason you use Alpine?
Yes, because it's small and convenient. So Alpine's a popular version. I did put some comments in the workbook that Alpine is small and convenient, however, it's got a couple of problems. One is that it uses a different package management system to the one you're probably used to. So that's a bit fiddly. The second thing is it's so small it comes without things like, it uses BusyBox for the shell and things like this, so limitations. Sorry? Yeah, so it's really cut down. So it's really useful for demos and for small prototypes and that sort of thing. But I'm always using Debian when I'm building this stuff. Tip for you is don't use Debian Stretch or Jessie or whatever. There's always a slim version, which is usually about 20 megs smaller. So it's a big cut down. So that works well for me. Does that make sense? I did say in the abstract that I would show you Docker Compose running. So I feel obligated to fulfill that contractual requirement. So I'll do that in a minute. Yep. You got the correct subdirectory. Look, make file set D your correct default, your current default. I've done my job correctly. Okay. Yeah, copy works for me. So if I go Docker container run.
I'll draw my question.
Works. Right. Okay, Docker Compose. So just a quick aside. First of all, I wouldn't recommend you start using Docker Compose until you understand Docker Container build and run, or sorry, Docker image build and Docker Container run properly and understand the nuances of Docker files and running them and so on. But once you've got that, then Docker Compose is a useful tool because it allows you to orchestrate multiple containers, not a huge number, but a few containers to create a working system. Now, I talked about Kubernetes and Swarm being for the hundreds of thousands, or even hundreds or dozens. Compose is for the few that you need to develop a working system, so maybe a database and a proxy and this, that, and that's the example I'm going to show you. And so it's quite useful, and you can actually put a lot of the information that you would scatter into Docker files and here and there into a single YAML file and just run it and it brings the whole thing up for you. So I'm actually using somebody else's Docker files, a guy called Brett Fisher, who runs what I think is a very good Udemy course on this. So all I'm going to do is to download one of his Compose files. And quick. It's just a YAML file, and it's specifying the images I want to use, the ports I'm going to expose, the environment variables I need, and all the other processes and SQL. It's going to bring up a clustered MSQL environment, but from one file. So if I go Docker compose -f compose 3 YAML, it doesn't work because I forgot something. Oh yes, you need a command. And so bring it up. So if it needs to, it will bring anything down. It doesn't need to. So it's now going away and bringing up all this infrastructure for me. Produces nice logs, color-coded, different colors, different containers. Sorry? Yeah, just from one command, it's bringing up 4 different containers, which includes a clustered MySQL instance. And the fact that I can do that on a laptop is quite impressive. So there it is. So that's it running, and on a little tiny laptop, I brought up a fairly complex environment. It's not an orchestration, but it is a way of sort of packaging an application, a traditional application that just needs a database server and a thingy and one of those and a couple of those. So for that sort of environment, it's great. Yep.
So is that essentially bootstrapping multiple containers, and then once that's finished, you just treat them as if they're standalone containers?
Yes, all it is a wrapper around all the other stuff. Yep. It's like running make instead of having to manually type CC and link and that. It's just it's a fancy make system for Docker. But in the same way that you wouldn't start, if you're a novice C programmer, you wouldn't start from make, you'd start from CC. It's the same here. You need to understand what's going on underneath the hood. And I think I'm officially out of time. So if you've got any questions, just follow up online. I knew we wouldn't finish everything because it's just too much to cover in the length of time we got. Thanks for all the questions, and I really enjoyed it.